All right, so let's return to this slide about the sample. And we said the sample must be representative, and we said, well, what does that really mean? And what we're going to do is we're going to replace that with randomness. But what does representative mean? Because intuitively you'd think this is exactly what you want. So I went onto the web and I found this place, Investopedia, and they define what they mean by a representative sample. And they say it's a subset of a statistical population. Now, I don't know what a statistical population is as opposed to just a population, but anyway, that accurately reflects the members of the entire population. Accurately reflects the members. So, and the example they give is in a classroom of 30 students in which half the students are male and half are female, a representative sample might include 6 students, 3 males and 3 females. I don't know what they mean by might include. I suspect they don't mean that if it might not include them either. I suspect they mean it should include 3 males and 3 females, because that would be representative of the population of 30 students, because half were male and half were female. Then they go on to say when a sample is not representative, the result is known as a sampling error. Don't believe everything you read. Now, using the classroom example again, a sample that includes 6 students, all of whom were male, would not be a representative sample. Whatever conclusions were drawn from studying the 6 male students would not be likely to translate to the entire group, since no female students were studied. Now, there's a couple of things wrong with that. First of all, okay, so this is what they're saying. They're saying that the population consists of 15 females and 15 males. So if we want a representative sample, it's got to be 50-50. So if we take 6, we've got to have 3 males and 3 females. All right. Why stop there, though? Suppose that in this classroom we judge students as being young for the classroom or older for the classroom. All right. Now, suppose that 9 of the female, 60%, were young, classified as young, and 6 were classified as older. And for the boys, for the males, it's the opposite. It's 6 are young and 9 are older. So not only do we need that we have 50-50, but we've also got to have, if it's going to be representative, we've also got to have that amongst the females we have 60% are young and 40% are older. And amongst the males we want 40% are young and 60% are older. So you can imagine what's going to happen once we start looking at other factors. Height. Some are tall, some are short. We've got to have the same representation of talls and shorts. Weights, you know, some are overweight, some are underweight, whatever. And very quickly, we're not going to be able to satisfy this. There's 2 things wrong with this. One is this fact that once we start looking at more and more and more factors, it becomes more and more and more complex, and we're going to get smaller and smaller and smaller cells, and eventually they won't be able to fill any of the cells with people. So that's problem number 1. Problem number 2 is how is it that you know this much about your population? You know how they break down by sex, you know how they break down by age, you know how they break down by weight, you know how they break. Okay, so why are you surveying if you know that much? So chances are we don't know that much. Okay, so we had this argument 100 years ago, and this idea of representative, because if you're surveying, it means you're ignorant about certain things. Okay, so who is going to decide what are the things that are important or what are the things that are not important, and how? And it turns out these, quote, authorities would decide the sample, and inference was impossible to do because you had to incorporate, to be correct, you have to incorporate the biases of the people who are designing the survey. And it's important. It's important to this day. For example, today the CDC has some study, and they have some numbers on this. Namely, if you take a survey and you use a telephone to take the survey, well, who do you phone? All right. In this country now, the preponderance of young people do not have a landline. They have cell phones. So do you include cell phones in your study or not? If you don't, you're cutting out young people. Okay? If you only do cell phones, then you're cutting out older folks. So how you choose who you're going to include in your, quote, representative sample is not an easy point. So what do we do? The point of all this is, if you have knowledge to bring to the table, by all means bring it. For example, if you know you have 50% female and 50% male, and sex will impact your outcome of interest, then make sure that your sample is 50% female and 50% male. Don't leave it up to chance, because chance is not going to give you 50-50. You know that. You've seen that from the quincunx. Okay? In the long run it will, but at any one shot it might not. All right? So by all means do that. So, but be careful. Don't use too many of these constraints. Don't say I want 50% male, 50% female, and then amongst the males I want 50% this, 50% that, and because once you start doing all that, then it becomes very much more complicated, and you lose the ability to estimate things. So for example, if you say you're going to have 50% male, 50% female, you cannot then look at your sample to estimate the sex ratio in the population, because you forced it to be exactly a half. So there's no information about that ratio in your sampling scheme. So it's a trade-off. Be careful with this trade-off. Okay. But let's resort and let's go on to simple random samples. And this is, as Laplace said, chance is but the expression of man's ignorance. And this is why we're going here, because now we're going to rely on chance. And what was it that we said about probability? We said that initially, in the short run, it's topsy-turvy. In the short run, we don't know what's going to happen. It's unpredictable in the short run, but it is predictable in the long run. And that's what we saw with the quincunx. We saw that at the bottom, every time the ball came out, it would bounce one way or the other. Bounce, 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 bounce. But somehow, after 19 bounces, it reached the bottom, and for the most part, it ended up somewhere in the center. Why is this? After 19 bounces, 19 lefts, rights, etc., why is it that it gave us this lovely bell-shaped curve? That's the magic of long-run probability. Why with the thalassemia? Why is it that half the kids will be carriers but won't have the disease? A quarter of the kids will be clear, and a quarter of the kids will have the disease. Why is it? Okay. This is what we get in the long run. And let's take advantage of the long run stability of these methods. And that's what we're going to base our inference on, is this long run stability. Okay? Now, what we want in order to ensure this long run stability, what we want is we want to know that everybody in the sample, everybody in the population has an equal chance of being in the sample. That means we need what is called a sampling frame. We need a list of all possible people who can go into the sample, and then we can ensure that each one has an equal probability of being chosen. It's an idealization, but what it also tells us is that the population is defined by the sampling frame. So they're one and the same. If you think that your population is everybody in the city, but you don't have everybody, you don't have homeless, you don't have home addresses for those people who are homeless, and you're going to go through a list of addresses, you're not going to have a representative sample. Your sampling frame there is not equal to the population. If your sampling frame consists of everybody who voted at the last election, you are not getting everybody in your town. All right, so the sampling frame defines your population. But then we forget about it and we just say population after that. But it is the sampling frame, because only then can we assure that everybody has an equal chance of being chosen. And we're going to use some sort of random device, and there's all sorts of random devices that can be used. But let's assume that we've got, let's not go down that road. Let's assume we have a random device that will allow us to take a simple random sample. Sometimes the samples are not quite as random as we'd like to believe. Here's, and I like the name of this, that's why I'm showing it to you. Psychologists speak about weird samples. And what they mean is, it's an acronym for Western, Educated, Industrial, Rich, and Democratic Subjects. So they're weird subjects. And why they say this is because typically, where are these psychological studies done? They're done on campus. And who comes in to do this for the $1 or $2 that they may pay for this are other students. And so this defines who those students are, typically. And what they found, or what they're finding, is that these weird students are not that typical of other cultures. So some of the cultural findings in these psychological studies do not extend, do not extrapolate to other cultures. Now, we do the same thing. We send our students off to the teaching hospitals, so that most of the studies most of the medical studies are done at teaching hospitals. And we need a sample. What do? We send the students off to, we need a sample of children. Well, there's a children's hospital just down the street. It's a wonderful hospital. It's fantastic and it's terrific. But, you know, are those children at that hospital representative of all children everywhere in the world? Now, we're not going to be as badly hit as the psychologists, because they're looking at cultural events, how people react to certain things, whereas we're looking more at the physiological, biological kinds of issues, which might extend more easily to other societies and all. But there's still a strong possibility that they may not. So we have to be very careful. And do we really have a representative sample? So even if we go to the hospital and say, all right, I just want a random sample of your kids, so I'll take every 10th one that comes in through the door. That's one way of doing it. Well, so even though we've imposed some sort of randomness, it might not be sufficient. But we just have to keep an eye open for that.